Number 1 says solve for x in the following triangle. If you notice, all of the things that are marked in this triangle are angles. So you need to remember that all of the angles in a triangle add up to 180 degrees. So you're going to make an equation that says that. Take each angle, 9x minus 16 plus 7x minus 5 plus 3x plus 11, and equal that all to 180 degrees. Combine your like terms, combine all of the x's. That was 9x, 7x, and 3x combines to give you 19x. Combine your numbers. You have negative 16 minus 5 plus 11, that gives you a negative 10, is equal to 180 degrees. We're going to add 10 to both sides. That's 19x is equal to 190. And you divide by 19, x equals 10. Always make sure you read the question. They only asked us to find x, so we're done. If they asked us to find the measurements of each angle, you would have gone back and plugged them in. Number 2 says, solve for all of the missing angles in the triangle below. I'm going to start by solving it for angle 1. If you notice, we have two triangles put together. I'm only going to focus on this red triangle at the bottom of my diagram. We know that this quarter angle is going to be 90 degrees because it's a right. The reason why is because they are alternate interior angles. So now we know that angle 2 is 52 degrees. We know that the top angle is 63 degrees, so we can solve for the missing angle because we have another triangle. In purple, I'm coloring in that triangle. So I know that 52 plus 63 is going to give us 115. And if I use 180 minus 115, it leaves us with 65 degrees. And that's going to be angle 3. The next one says, solve for x in the following triangle. Look at the triangle and notice that we have two sides being marked. These two sides mean that the two sides are equal. If the two sides are equal, we call this an isosceles triangle. If two sides are equal, the angles across from them are also equal. So if the top left corner is 9x plus 1, I know that the top right corner will also be 9x plus 1. Take a step back and realize that we've now marked all of the sides in the triangle, all of the angles in the triangle. All angles of a triangle should add up to 180 degrees. Pretty similar to question number 1. Now that you have your equation, go ahead and combine your like terms. You end up with 18x. 1 plus 1 plus 88 is 90, is equal to 180. Subtract 90 from both sides, you get 18x is equal to 90. And divide x is equal to 5. As always, make sure you're answering the questions. This question asked us to solve for x, so we're done. But if it asked us to find the angle measurements, you would have needed to go back and plug it in. Number 7 says if triangle PQR is congruent to STU, complete each part. What I'd recommend before answering the questions is make sure that the problem is marked up correctly. We know that angle P matches up with angle S. They're in the first position. So if P is 59, S will also be 59. And I mark it on the picture. Notice angle T is marked as 75. T matches up with angle Q. That one is also going to be 75. I know that all three angles in a triangle should add up to 180, which leaves me with 46 for the two missing angles. I also know that side PQ, those are the first two letters, should match up with side ST, so I'm going to label ST with a 7. I know that PQ, we did PQ. PR, it's the first and the last, will match up with SU, so I'm going to label that with an 8. Now I have them all labeled, answering the problem should be easy. ST is going to be labeled as 7 meters. SU is going to be 8 meters. Angle R is 46 degrees. Angle Q is 75 degrees. And angle S is labeled as 59 degrees. So again, label as much as possible before you start, then answer the questions. Number 5 says, what method can be used to prove that the two triangles are congruent? Before you start, you should ask yourself, is there anything here that you can mark that hasn't yet been marked? And the answer should be yes. You can always mark your vertical angles. Those are angles that are across from each other. Now look at what you've all marked up. It might help to mark them with A's and S's. So we have a little S here, we have an A here, and an A here. Looking at it, that would be angle, angle, side, which is answer choice B. The reason why it's not answer choice C, angle, side, angle, is because that side is not in between your two angles. Similar question for number 6. It says, what method can be used to prove the following triangles are congruent? I'm going to ask you the same question. Is there anything on this picture that you haven't yet marked? The answer should be yes, that we can mark the reflexive side. Now that you've marked the reflexive side, that's the side that's shared in the middle, look at the things that you've marked up. We have a side here, and the third side in the middle. That would give you side, 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 which is answer choice A. I'm going to quickly talk about the two incorrect answers, side, angle, side, and HL. I think that students might pick those answers if they assumed that we formed a right triangle in the middle. Don't make assumptions. Only go based on the information they give you. Now we have a proof question to fill in. Notice we start with givens and they're giving you a picture. They're saying that line LN bisects angle KNM. I'm going to highlight KNM in purple. That is the angle that's being bisected. When we see the word bisect, we need to think that it's cut in half, cut into two equal pieces. So those bottom two purple angles would be equal. Similarly, it bisects angle KLM, the red one on top. Bisecting cuts an angle in half, so the two top angles would be equal, the two I'm labeling in red. That's all the givens start with, so now we're going to fill in our proof. We know that NL bisects angles KNM and angle KLM, and that was given to us. We're always going to start with our givens. Now talk about the information you marked up on your diagram. Let's start with the purple angles. Angle KNL is congruent to angle MNL. Those were the two purple angles on the bottom. We know that by definition of a bisector. Similarly, the two red angles will be equal. Angle KLN is going to be equal to angle MLN. For the same reason, definition of a bisector. That is what a bisector does. If you look at the picture, there's something else that we can mark. It's that shared side in the middle. LN equals itself. LN by the reflexive property. Finally, you're going to end with whatever you're trying to prove. Triangle NKL is congruent to triangle LMN. If you look at what you've marked an angle, a side, and an angle. The next problem asks, which of the following could represent the side lengths of a triangle? If they're giving you 3 sides of a triangle, you need to remember that the small side plus the medium side must be strictly greater than the large. And let's check out our answer choices. In the first one, you want to add 11 plus 17. When you add them, they're bigger than 19, so this answer choice is correct. I'm going to shade it in. In the second one, again, you want to add your 2 smaller sides, the small side and the medium side, and see if it's bigger than the third. In this case, it is not bigger than the third, so we can cross that one off. That would have been a less than. In the third one, we want to add 9 plus 25. In that case, it equals 34. That is not a correct answer either. And for the last one, add 13 and 14, and that will be greater than 22. So the fourth answer choice is correct as well. Next problem asks you to order the sides in order from shortest to longest. Please make sure you follow the directions. Before you start, you should always fill in any missing angles inside of a triangle. We know that all of them should add up to 180 degrees, and that leaves us with 68 degrees for angle D. Now, the shortest side in this triangle will be across from the smallest angle. The smallest angle is E, which makes the smallest side DF. The medium angle is F, which makes the medium side DE. And the biggest angle is 68, so the longest side is EF. The answer choice that states that is answer choice D. Remember, it doesn't matter if you named it DF or FD when you're naming a side. This problem says that 2 sides of a triangle measure 17 inches and 9 inches, which cannot be the length of the remaining side. If you're going to see 2 side lengths in a triangle, I want you to think of the inequality that we make. In order to fill in the numbers in the inequality, you want to take your 2 numbers and first subtract them. 17 minus 9 will give you 8. Then you want to add them. 17 plus 9 gives you 26. Any number between 8 and 26 will work for the third side. So we want to find a number that is not in between 8 and 26. A is in between, that works. That would make B, 26, the correct answer, because we want it to be strictly less than 26, not on the edges. I think this is an interesting problem because it requires a lot of knowledge about triangles. So first it tells us that WXY is an equilateral triangle. If you know it's an equilateral triangle, you know that all angles are equal and all sides are equal. In WZY, it's isosceles. It has 2 equal sides and 2 equal angles. Let's start off by looking at the large equilateral triangle. If it's an equilateral, all angles are the same, which means each angle should be equal to 60 degrees. I know that angle 1 will be 60 degrees. Now I'm going to look at the isosceles triangle on the bottom. It tells you that the top angle is 138, so let's see how much is left over from 180 degrees. If I do 180 minus 138, that leaves us with 42 degrees between angles 3 and 5. I know that angles 3 and 5 will be congruent because it's isosceles, so I divide that by 2 and I get each one of those angles is going to be 21 degrees. So angle 3 is 21 and angle 5 is 21. Finally, we need to figure out what angles